Hey guys, today we're going to talk about the six trigonometric ratios. So far, we've been working with the three sides of right triangles. So here we've got an example of a right triangle, and we've been using the Pythagorean theorem, a squared plus b squared equals c squared. So we've been working with the three sides. But today we're going to add angles to our toolbox of things we can do with right triangles. So the key to working with right triangles is labeling them correctly. So we're going to label them in a new way. We're going to start by choosing what's called a reference angle. And remember, math words a lot of times have smaller words in them. So a reference angle is an angle that you're going to refer to. And we're going to mark it with a theta. So this is a Greek letter. And you might be saying, I already hate the fact that there's regular letters in this. Why are we adding Greek to the mix? It's because mathematicians decided that Arabic letters, so A, B, C, D, the alphabet would be used for sides, and that Greek letters would be used for angles. So here we're going to pick this angle to refer to focus on, and we're going to name the other sides based on this reference angle. Now, sometimes students like to draw a little stick figure there to help them think about if there's a person there, how can that help me label the other side? So it's not required, but for some people it helps, so I'm going to show you. So we always start by labeling the hypotenuse. We're going to use the letter H, of course, and the hypotenuse is across from the right angle no matter what. So we always label the hypotenuse, doesn't matter where our reference angle, this is going to be the hypotenuse because it's across from that right angle, always will be. Then we're going to look at the opposites. So there's two sides left. There's this side right here, and there's this side right here. So how do we know which one is the opposite? Well, one of these sides is touching the reference angle. It's right next to the stick figure. The other one is away, opposite from him. So the opposite is always going to be the side that's not touching your reference angle. So opposite, we label with the letter O, and it's the side farthest away from your reference angle. And then last, the adjacent side. Adjacent is just a fancy word for next to. So the adjacent side A is the side next to the reference angle. And you might be saying, well, aren't there two sides next to the reference angle? Yes, but the hypotenuse is already taken care of. So this last side is going to be the adjacent side. So there are 6 trig rules that are always true when we're given two sides and one angle of a right triangle. And that one angle is that theta that we look at, that reference angle. So here are the 6 trigonometric ratios. Here we go. Sine of theta is equal to O over H. Cosine of theta is equal to A over H. And tangent of theta is equal to O over A. So you might have seen this as SOHCAHTOA. Now, I grew up in Asheville, North Carolina. I don't know if you know a lot about Asheville. I promise you my teacher told me this. She said, remember, some old hippie caught another hippie tripping on acid. I know, ridiculous. So those are the 3 main trigonometric ratios. And if you can remember some old hippie caught another hippie tripping on acid, or some old horse caught another horse taking oats away, you can remember these 3 trig ratios. But there's 3 more, and they're easy to remember too. There's cosecant. So every trig function has a co that goes with it. So if it already has a co, its counterpart does not have a co. And then tangent and cotangent. So there's a co in every pair. So we write cosecant like this, and it is related to sine because it's the reciprocal. That's just a really fancy way of saying it's upside down. So cosine and secant go together, and it's the reciprocal. So this will be H over A, and then cotangent goes with tangent, and it is the reciprocal A over O. So these are the 6 trigonometric ratios. So let's take a look at this one. The theta got a little bit messed up when this printed here. So let me fix that theta, put it right there. So use a previous skill to find the length of the missing side, and then write the 6 trigonometric ratios for theta. So first thing we want to do is find this missing side. Now, since this is a right triangle and we know how to work with three sides, two known and one unknown, we can use the Pythagorean theorem. We can use a squared plus b squared equals c squared. So 12 squared plus 16 squared equals c squared. So go to work on that. 400 equals c squared. So 20 is equal to c. So this missing side is 20. So use a previous skill to find the length of the missing side. Done. Now let's write the 6 trigonometric ratios. And in order to do that, we want to use theta as our guide. So we're going to start by labeling the hypotenuse. Now remember, the hypotenuse is always across from that right angle no matter what. So our hypotenuse is going to be 20. Then our opposite side is always farthest away from theta. So our opposite is going to be 16. And now adjacent is going to be the leftover side that's next to theta. So we've got our H, O, and our A. So what we're going to do is we're going to write our 6 trig ratios. And instead of writing the word or the letters O and H, we're literally going to write 16 and 20 because those are the values for O and H. So let's start that now. So sine of theta is 16 over 20. Cosine of theta, that's A over H, so A over H is 12 over 20. And then tangent of theta is O over A, so 16 over 12. Now these can be reduced a little bit. We can reduce this to 4 over 5. We can reduce this to 3 over 5. And we can reduce this to 4 over 3. But those are the first 3 trig ratios. So now we're going to find the other 3 by flipping them upside down. Remember, every function has a co that goes with it. And if it's already a co, then its counterpart isn't. So here, sine does not have a co, so its counterpart is cosecant. And that is going to be 4 over 5 flipped upside down to 5 over 4. Cosine already has a co, so its counterpart is just regular secant, and it's going to be 5 over 3. And then finally, tangent does not have a co, so its counterpart is going to be cotangent, and it's going to be 3 over 4. And that's how we write the 6 trigonometric ratios. So now let's actually evaluate some of them. Doing it in your calculator is easy, but you have to make sure that you are in degree mode. Even if you're in Desmos, you've got to be in degree mode. All right, so here's Desmos pulled up. In order to make sure you're in degree mode, you'll click on this wrench in the top right corner to change your settings. And down at the bottom, radians is currently selected. You're going to want to change that to degrees. Once you've changed that to degrees, you're good to go. So if we go back to our notes, we're going to find the sine of 52 degrees. And I'm just going to do all of these at one time. This is going to be very easy to do with Desmos. Once you have verified you're in degree mode, the rest is just typing things in. So we'll type sine of 52 degrees. And you don't have to put the degree symbol because it's already implied to be there since you put it in degree mode. There might be a degree symbol somewhere. I don't remember where to find it. So we're not going to worry about it right now. At any rate, just make sure your calculator is in degree mode. You'll be fine. So sine of 52, cosine of 67, cotangent of 81, and secant of 72. So no big deal. We've got all those values. So let's go back to our notes and fill those in. We got 0.788, 0.391, 0.158, and 3.236. All right, so now let's bring it home by using our trigonometric ratios to find the missing length. We are going to put it all together. So first of all, we're going to put our reference angle on here. Your reference angle is never your right angle. It's always one of the others. We're going to choose 64 because why? Well, the alternative is this empty spot. Now, could you find the empty spot? Sure, but it's always easier to work with what you're given. So 64 is going to be our reference angle. And if you want to put your stick figure there, if that helps you think about it, go for it. So we're going to label the hypotenuse, which is always across from the right angle. And then the opposite is the side farthest away from your reference angle. And then this side over here is going to be the adjacent. but it doesn't have any information. So if you want to label it, you can, but which two sides are we going to work with? Well, we're going to work with the H because it's what we're given, and we're going to work with the O because it's what we're going to want to find. So which trig ratio are we going to use? Which one has O and H in it? Well, the sine ratio has O and H in it, so we're going to use the setup of sine of theta is equal to O over H. So let's replace theta. We know theta is 64 degrees, so we're going to say the sine of 64 degrees is equal to O, so x over H 25. The hard part is writing that equation down. Once we've got it, now we get to use our algebra skills to solve for x. So we want to get x alone. Right now it's being divided by 25. So how do we undo division by 25? We multiply both sides by 25. So both sides we're going to multiply by 25. You can go to your calculator and do that. 25 times the sine of 64. Let me clear this out. 25 times the sine of 64, and we're still in degree mode. And so we get that that missing side is 22.47. So 22.47 is equal to x. Let's try another one. Let's start by finding our reference angle. Oops. So our reference angle is right here. We're going to label the sides we care about. We know this is the hypotenuse. You can put an H there if you want, but since there's nothing there, it's not the most helpful. Here we've got opposite, and here we've got adjacent. So since we've got O and A labeled for us, we're going to use the trig function that has O and A in it. So if we go back here, tangent is the trig function with O and A in it. So we're going to set up a ratio. Tangent of theta is equal to 9, or O over A. I'm just going to write that over here and then fill it in. So tangent of 35 degrees is equal to 9 over x. Okay, so this one is a little bit different than the previous one because here x was on the top, but over here x is on the bottom. What do we do when x is on the bottom? Well, there's a little trick we can do, and this is mathematically sound. If we put this over 1, then we can cross multiply, and then we'll end up dividing by the tangent of 35 degrees. So here's the trick. If x is ever on the bottom and you want a little shortcut, you can swap the denominator with the entire left side. So we'll get that x is equal to 9 divided by the tangent of 35 degrees. Now, if you want to diagonally multiply and show your work, you can do that. But if you do this and then put this in your calculator, you'll end up getting that missing side, that x right there is equal to 12.85. All right, so remember when x is on the bottom, do a little swap. Let's try this last one. So this last one, our reference angle is right here. So let's label our sides. We've got, this is the hypotenuse, this is the adjacent side. So we're going to use cosine because cosine has A and H in it. Cosine of theta is equal to 18 over x. Sorry, I get ahead of myself. I just want to write down the regular ratio A over H. So cosine of 30 degrees is equal to 18 over x. So again, if x is on the top, you're good to multiply. But if x is on the bottom, do a little swap. And again, if you diagonally multiplied, if you put that left side over 1, you would get this anyway. But this is a little shortcut that makes life a little faster. So x is equal to 18 over the cosine of 30 degrees. Again, take a moment to put that in your calculator. You'll end up with 20.78. All right, we're almost done. We've just got 3 more to go. Now, what's different about these is this time, all the angle measures are what we're going to find. So what do? Well, we're going to use inverses to help us find the missing angle. We're going to use trigonometric inverses. So I'll show you how. So here, let's label the sides we've got. We've got opposite and adjacent. So we're going to use a tangent ratio. Tangent of theta equals O over A. In this case, tangent of theta is equal to 8 over 14. So now our job is to get theta by itself, and that theta is stuck inside of this tangent function. So how do we make tangent go away? Well, just like we undo adding with subtracting or multiplying with dividing, we undo tangent with an operation called inverse tangent. You can write this one of two ways. You can write this, it looks like tangent to the -1, but it's not. Remember when we talked about inverses? An inverse function f of x, its inverse looks like this. It just means that they undo each other. So tangent to the -1 doesn't actually mean to the -1. It just means that it undoes tangent. So we're going to do the inverse tangent of both sides. We're going to do the inverse tangent over here as well. So what's going to happen is the tangent and inverse will say goodbye to each other and we'll be left with theta. And then we can type the inverse tangent of 8/14 into our calculator. So inverse tangent of 8/14. There we go. And another thing you can do, there's another name for inverse tangent. It's called arctangent. It means the exact same thing. As you can see, these answers match perfectly. They mean the same thing. So you can use the inverse tangent or arctangent notation. They mean the same thing. They're just written in two different ways. So I don't care which one you use. I use them interchangeably. Obviously, you'll get the same answer, which is 29.74. And since you're solving for an angle measure, make sure you put degrees on the end of that. All right, two more to go. This one we've got adjacent and hypotenuse. So we're going to use cosine of theta equals a/h. So cosine of theta equals 38/40. So now again, we want theta. We need to make cosine go away. So we're going to find the inverse cosine of both sides. Inverse cosine, inverse cosine. Cosine and inverse cosine say goodbye to each other, and we're left with just theta. And then over here, we're left with inverse cosine of 38/40. So go to your calculator, type it in. Remember, you have choices. You can type inverse cosine like this. Was it 38/40? Or you can type inverse cosine like arc cosine. Again, they mean the same exact thing. And you get the same answer, which is 18.19. And since we're solving for an angle, that's going to be in degrees. All right, last one. So this one, we've got opposite over hypotenuse. So this is a sine problem. Sine equals O/H. So sine of theta is equal to 17/22. Theta is inside of sine. We want to make sine go away. So we're going to do inverse sine of both sides. So theta is going to be equal to inverse sine of 17/22. And that will result in your angle being 50.60 degrees.